Alright, so welcome back. So we're going to try a few more, just a little bit more practice problems, just to get us used to it. So again, just like with derivatives, we really don't like radicals, so we want to write them as an exponent. And I can rewrite the cube root of x as just x to the 1/3. And again, don't forget the dx. When I integrate, remember, we're undoing a derivative, and our derivative always tells us that we're going to drop our power and subtract. We do the exact opposite. We're going to add 1 to our power. So what is 1/3 plus 1? Well, this is just 3/3, or just x to the 4/3 over 4/3. Now, remember, this is a derivative right here. That's all this is really telling us. This is a derivative. And when we want to write it as the original function, there was a constant there. But we don't know what it was, so we just leave it arbitrary or unknown. And my last thing, I don't like this 4/3. So a couple things I can do. One, in the previous videos, I just multiply both top and bottom by 3. Or right here, I can just invert and multiply. And that just becomes 3/4 x to the 4/3 plus c1. And there's a final answer. For the second example, again, I don't like the way it's written, so I could write this as x to the 1/2 minus 4, and I'm going to bring this x up, x to the -1/2. And again, don't forget to rewrite the dx. Rewrite your powers. This becomes plus 1, so we're going to add powers. We're going to plus 1. So we get x to the 3/2 over 3/2, because we're going to divide by that new power, minus 4x, and if I add 1, well, -1/2 plus 1 is a positive 1/2, and again, I divide by that 1/2, and then I just add my constant of integration there. And then for both of these, I'm just going to invert and multiply. So I get 2/3 x to the 3/2 minus, now when I invert the 1/2, that's going to become 2 times 4, or 8x to the 1/2, plus your constant of integration, that's c1 right there. Don't forget this. Don't forget, this is very important, because remember, that constant is telling us that this, we don't know what that original constant was, but it became 0, so we need to put that plus c1 right there. And for our last one, it's already in exponential form, so my rule says just add 1. So what is 2/3 plus 1? Well, if you need to go to the side, that's just 2/3 plus really 3/3, which is 5/3. So our answer is going to become x to the 5/3 over 5/3 plus, don't forget your constant of integration. In inverting and multiplying, we will get 3/5 x to the 5/3 plus c1, and there is our final answer. Alright, I hope you enjoyed these videos. Smash that like button, and I will see you all later. Bye-bye.